Okay, here we have a question where you can see we've got a sector of a circle. You're going to be using those formulae you've memorised. But in part A, what we've got to do is find theta from the lengths given on the diagram. It's a show that question. This is your end point, so ignore that to begin with. Think about how you'd find theta in this triangle. There are really two approaches. You could use the cosine rule, or because we've got 24 twice, it's an isosceles triangle, so it is possible to split it into two right-angled triangles and work with just half the angle to begin with, and then double up to find theta. When you're getting to a show that of a decimal answer, what you need to do is get a more precise answer for theta first, more decimal places than that, and then show it rounds off to this, and that's the way to be convincing. Then in part B, now we're into our formulae. We want the length of the arc AB, so that's your formula that begins arc length, often S, equals, there's a formula from your chapter 4 booklet that you need to have learnt. Quote that formula, plug in values for a radius and for an angle, and you'll get the arc length. Then we need the area of the sector, so you've got several formulas for area. You've got triangles, you've got sectors, you've got segments. This is the A equals formula for the area of a sector ABC. Again, learn it from your notes, quote it, put the values in. And then hence, that means using what you've just done. So in fact you may all have learned a formula on its own for the area of a segment, which is basically the sector take away the triangle. That's what it wants you to do. You can quote that formula because it clearly contains what you've done there, or you can work out the area of the triangle and subtract it, and that's how you get the area of the shaded segment there.